let me introduce today's speaker, Esha Chauhan, the student of industrial chemistry course, BSc 503. It's an honor to listen to Esha on the subject called water electrolysis, which is a very potential energy source. It is a very potential energy source for hydrogen green fuel. Okay, when we use hydrogen as a fuel, there will be literally no carbon footprint. There will be no greenhouse emissions. If we succeed in water electrolysis problem, we have a potential energy source at our disposal. I'm happy that the topic has fallen in the hand of Esha, and at a very short notice, Esha is successful in preparing the PowerPoint presentation, and I now request Esha to speak to us on water electrolysis.
Good morning, everybody. The topic for my presentation is water electrolysis. So, what is water electrolysis? Electrolysis of water, also known as electrochemical water splitting, is the process of using electricity to decompose water into oxygen and hydrogen gas by electrolysis. Water electrolysis is a popular method used for different applications in various industries, mainly in the food industry, power plants, amongst others. Besides the component of water, which include hydrogen and oxygen, there are many applications. For instance, hydrogen obtained through electrolysis is a clean, renewable and efficient fuel source.
Yeah, excuse me, Esha. This is what exactly I have spoken in the introduction. You see, Esha has clearly told to us why are we dealing with this. Unfortunately, this is missing in our syllabus, in our curriculum, hydrogen energy. Maybe in the next semester, I want the subject of hydrogen energy to be included in the curriculum. If you read the last sentence, I will read for you. For instance, hydrogen obtained through water electrolysis is a clean, renewable and efficient fuel source. Please go ahead, Esha.
So, however, the electrolysis of water is not simple and easy for many reasons. Water is very weakly dissociated into hydrogen and hydroxide ions. The concentration of the ion in neutral water is equal.
What is the dissociation constant value of water? H2O giving rise to 2H plus OH minus? Yeah, it is such a low value. That is the problem Esha is trying to introduce to us. Water is weakly dissociated into hydrogen and hydroxide ions. The concentration of ions in neutral water is equal to something is missing here. Okay, please go ahead.
Electrolysis involves the charge carriers for the current to flow. So water with a very small amount of ions is a bad conductor of electricity. So the electrolysis of pure water will be a very slow process. The hydrogen ion is associated with other water molecules and existed as a hydronium ion. So any hydroxide ion moving towards the anode will be neutralized by the hydronium ion even before it reaches the anode to form oxygen gas. Similarly, any hydrogen present will be neutralized by the hydroxide ion present near the cathode and will not be reduced to hydrogen. So the electrolysis of water to hydrogen and oxygen will be a very small. The electrolysis also involves the transfer of electrons from the anion to the anode and cathode to cations. So this is the figure.
Yeah, beautiful. Yeah, this is always confusing. Thank you very much, Esha. You are the one beautiful student that made me happy. In most of the papers I have sent, they have beautiful pictures. Unfortunately, the students, telling that, they have problem with copyright, they have problem with, laptop, they have problem with mobile phone. So many stories. I missed many beautiful figures like this. In almost all of the papers, there are beautiful pictures related to the problem. Yeah, thank you for showing the schematic representation of, water electrolysis, showing beautifully the positive electrode called anode, the negative electrode called cathode. You cannot take for granted that it is trivial. What is trivial to Esha may not be trivial to me, Yeah, you should speak in a clear way, present the topic in a clear way, like what Esha is doing. Thank you, Esha, for being clear. I have many confusions. You cannot take for granted that it is trivial to a person with 20 years of research experience. Nothing is trivial. Yeah, please. Yeah, present Isha. No. The previous slide. Yeah, here students please follow what is happening at the positive electrode called anode where oxidation takes place and cathode where reduction takes place. The anodic reaction and the cathodic reaction are shown here. Okay. Hydrogen is evolved at the anode and at the cathode hydrogen is reduced. Yeah. Please Isha, continue.
So the factors affecting the efficiency of electrolysis. First, the number of available cations and anions in the solution. Second, mobility rate of the ions to reach the electrode. Third, the activation energy that is needed for the electron transfer from the electrode to the electrolyte ions. Fourth, the effect of the gas bubble surrounding the electrode on the further electron transfer, etc. 5. Crossing over the several interfaces results in the increase of energy requirements for the electrolysis then predicted by the thermodynamical gives energy. Principle of water electrolysis. Two electrodes or plates that are made from an inert metal such as platinum or iridium are placed in the water. A DC electrical power source is connected to these plates. At the cathode part, hydrogen will appear on the anode side. Oxygen will appear if we consider the ideal spreading efficiency. Hydrogen will be produced twice the amount of oxygen. On the other
Please repeat this sentence. Hydrogen is produced twice the amount of oxygen. Why? Yeah, 2:1 molar ratio. That's what Isha is telling. Yeah, please go ahead, Isha.
If we consider the ideal kinetic efficiency, hydrogen will be produced twice the amount of oxygen. On the other hand, both will be proportional to the total electric charge conducted by the solution. However, in some cells, side reactions can occur and different. Products are formed with less than ideal kinetic efficiency. When two or more ions of similar charge are present in a similar condition in the solution, one is preferentially selected for discharge. This depends on first, the position of the metal or group in the reactivity series, second concentration, third the nature of the electron. So this is the first position of the metal or group in the reactivity series. Any ion will be discharged from solution in preference to the above this one. Second, concentration. Increase of concentration of an ion tends to promote its discharge. Third, nature of the electrode. Inert electrodes like carbon graphite and platinum are not affected by ions surrounding them. Reactive electrodes like copper or silver can affect the order of discharge. For example, in the electrolysis of copper sulfate solution, if inert electrodes are used, oxygen is evolved at the anode. But if active electron like copper is used, copper is dissolved at the anode. Cell potential and thermodynamic feasibility.
Beautiful. Yeah, this is very important slide in all of the paper. Okay. See the reduction and oxidation potentials at the cathode. What is happening? Water is reduced to give H2 plus OH minus, and at the anode what is happening? H2O giving rise to water. Yeah, the net reaction and the cell potential for water electrolysis is shown in the last equation, H2O giving 2 moles of hydrogen and 1 mole of oxygen with a potential value minus 1.24 volts. Yes, please go ahead.
So Hausser reaction with the electrolysis of pure water at pH is equal to 7 and the 25 K at cathode, the reaction will be 2H2O plus electrolysis of water is given as 2H2O, it will give 2H2 plus O2. The cell potential of electrolysis of pure water is negative and hence is thermodynamically unfavorable because of the low concentration of ions and the interfaces to be crossed. Electrons and extra voltage at each electron is needed to be above 0.6 volt. In practice, continuous electrolysis of pure water is possible only at an external voltage of 2.4 volt. Since the electrolysis of pure water is thermodynamically non-feasible, methods to make it kinetically feasible are being investigated. One of the methods is to increase the conductivity by increasing the number of ions available by adding acid, base and non-reacting salts. The electrolyte for water electrolysis. It is very important to choose the right electrolyte for water electrolysis. Why is it important? If we look at the anion from the electrolyte, it usually competes with the hydroxide ion to release an electron. If an electrolyte ion is a less standard electron potential than hydroxide, it will be oxidized instead of the hydroxide. Therefore, oxygen will not be produced. In the case of cation, if it has a greater standard electron potential than a hydrogen ion, it will be reduced. In this case, hydrogen gas will not be produced. Electrolyzers. The electrolytic cell used for the electrolysis of water is the electrolyzer. Depending on the transporter of the electrolyzer can be divided into three types. First, copolymer electrolyte membrane. Electrolyte membrane.
Sorry. Why pole is written two times? It's polymer electrolyte membrane. That's all. Polymer electrolyte membrane. Electrolyzer. It is polymer electrolyte membrane. Electrolyzer. That's all. Electrolyzer, Weimar, there is some mistake here, okay?
So it is polymer electrolyte membrane.
Yeah, after that also there is another mistake, electrolyzer, Why two times, why do you repeat yourself? Please go ahead.
A polymer such as nephine separates
Nephyon
separates the electrode and allows hydrogen ion formed by the oxidation of water at the anode to pass through it to the cathode compartment for discharge and form hydrogen gas. The alkaline electrolyzers. Dilute aqueous sodium hydroxide used in the electrolyze provides a movement of hydroxide ion to the anode to form oxygen. Solid oxide electrolyzer. Ceramic oxide separates the electrolytes at the cathode. Water is reduced to hydrogen and oxide ions. The oxide ion passes through the ceramic oxide to the anode to become oxygen gas. This is used at high temperature of 700 to 800 degrees Celsius to reduce the external voltage needed for the electrolysis. Electrolysis of pure water. An excess amount of energy in the form of low potential is usually all required for the electrolysis of pure water. This excess energy is extremely important because without it, the process occurs very slow and sometimes not at all. The limited self-ionization of water is also a reason for this. Moreover, the electrical conductivity of pure water is about 1 millionth than the sweeter. In such cases, the efficiency of electrolysis can be increased by using the proper electrolyte such as the salt and acid or a base along with the electrolytes.
Along with electrocatalyst. Yeah, the potential of electrolyte is discussed here. We must thank Esha for a very clear presentation. You are blessed and gifted with beautiful voice. Your voice is clear and audible, and thank you for presenting to us the problem of water electrolysis. How the water electrolysis is thermodynamically non-feasible. How are we trying to make the water electrolysis kinetically effective? All these aspects were presented to us by our friend Esha Chauhan at a very short notice. Thank you for introducing to us the very fundamental electrochemical reaction of water electrolysis. but you have missed the bus. There is some content that is related to corrosion and its impact on the relative amounts of hydrogen and oxygen that is produced in the water electrolysis. That is what about all about the paper. I do not know why you have missed the effect of corrosion on the yields, the relative molar ratios of hydrogen and oxygen. You did not speak anything related to corrosion. Is there nothing like corrosion in the paper? You missed something. Why? Okay, you want to be brief. Okay, but the paper contains beautiful discussion on corrosion and how it is affecting the relative ratios of hydrogen and oxygen in the electrolysis product, depending on the container of the electrolytic cell, depending on the presence of ion containing systems. I really wonder how Isha could. Oh, क्या हो गया? No. I want this presentation. You are threatening me like anything. Yeah. Devanshi Bharat's presentation I missed. She has presented so beautifully. I do not want to miss another presentation. Thank you very much, Esha. But you missed some important aspect in the paper. That is why I wanted the paper to be presented. It has some relevance with corrosion and its impact on the relative amounts of the relative ratios of oxygen and hydrogen that are evolved in the electrolysis process. That point was not at all brought about and that point was not at all discussed. If time permits, I request the students to read that particular point related to corrosion. Okay. Let us give a big hand to Isha for presenting the water electrolysis lecture. Big hand means louder.